Welcome. On this channel, I make unedited, unscripted videos about Linux programming and stuff. Most recently, I have been relearning C. It's been 25 plus years since I've done any C programming. I'm really only just getting started with that. In the previous video, I was exploring just the basics of reading a file, using malloc, etc. In this video, I'm going to continue kind of down that path of the exploration of memory management. So I think what I'm going to do to start is I'm going to drop into this little project folder and create a new folder or a new copy of the application for this video. So we want a copy of 0117. Which is going to be 0118, and I think, I think the thing I'm going to explore is it C continue? It's the continuous malloc, right? So let's see, malloc. Is that what it is? No. So there's malloc here. Let me do it a different way. There is malloc, calloc, which is continuous allocation, right? So over here, I want to probably search, although this might be good enough. So calloc, the function allocates in here. The function allocates memory for an array of n member elements of size bytes each, and returns a pointer to the allocated memory. The memory is set to 0. If nmem or size is 0, the calloc returns a unique pointer value that you can later be successfully passed to free. If the multiplication of nmem and size would result in integer overflow, then calloc returns an error. By contrast, an integer overflow would not be detected in the following call to malloc, with the result that the incorrectly sized block of memory would be allocated. So I guess they're clearly suggesting that calloc is a safer way to allocate memory. So I still need that 017 is going to be 018 calloc. Right, that's what we're going to do. So let's take a look at what we already have here. 018, make it clean. If I look in the source file, if I look in here, you can see what we're doing is we're iterating over all of the command line arguments. We're assuming their file names. We try to open the file name. If we successfully open it, we allocate a buffer matching its size. We read the file into the buffer, and then we iterate over all of the bytes in the file, outputting them, and then eventually we free close the file and return. I think that the first thing that I want to do is let's put this into, I think, what are we going to have here? The only thing we probably need is we need to return the, let me finish a sentence. I want to move a bunch of this out into just functions. So the first one is going to be, I'm just going to call it load file, and it's going to return that allocated memory. So buffer is a character pointer, is what we're returning, and we're just going to call this load file. It's going to have to take everything necessary to load that file, which is should be just the file name, right? So here we are using argv is what we want to, so the way we want to use this will be to, it's going to take the place of, right, of all of this code, and maybe that's the way to do it, is just to copy it out. So what we're going to do here is, we're going to need bytes read also. So bytes read is probably what we're returning. And the buffer will be something we pass. The pointer to the pointer will be what we pass in for it to overwrite. So what we're going to call here, though, is, so the way this is going to have to work is bytes read equals load file. Yes, we're going to pass in argv, but it's not the only thing. We also have to pass in, I think that the normal way to do this is the things that are being overwritten are always on the right-hand side of the argument list. I'm not really sure about that, or why I even think that. But we're going to pass the address of buffer, right? Because we want to, we want it to fill that. So up here, arguments are argv. So this is just going to be a character pointer called file name, and this is going to be the yep. It's just going to be like so. Now, wherever we used argv, we need to use file name instead. Right. What we need to return down here is going to be bytes read. But, oh yeah, we don't have to do anything else because we're populating when we hold it. When we do the malloc here, we are going to do it. So we need to set that. I'm not sure of the syntax here. So we can, I think we do it this way. So I think I could do it this way. So I could say that, hey, malloc is setting. No, I don't need to, though. I just need to say that it is setting buffer, I think. We'll find out if I'm doing this wrong. And then we set that. Okay, so if we have a if we have a load file, we're gonna have to have a free file. And in free file, let's just assume I don't know that it has a return value yet. Free file. We're clearly going to be passing in that same. I guess we could pass the thing. Right? I think that would work. Okay, so let's come down here and say this seems to be right because we have a character pointer called buffer. We pass the address of that character pointer to here, which ends up looking like a it's a pointer to a pointer of the type character. It's a pointer to a character pointer. The only part I'm not sure is if this is the correct way for me to dereference that first layer of pointer, right? And it'll blow up in my face if it's not right. But assuming all of that, before we return, we're going to want to close the file. All right, we want to make sure that the file gets closed. And these continues no longer make sense because we're not in a loop here. So instead, what we want to do is just return -1. So how does this work down here? So right, if we return a value that's less than 0, it's assuming that we failed, right? And so what we do is, if we fail, we return from the point with -1. And if we fail here, we return -1. Here we succeeded, so all we do is we close the file, and then we return bytes read, which will be a positive number, right? Okay. Down here, we check to see what we're going to want to do is we just want to, if we failed, so if bytes read is equal to -1, let's actually see what I was suggesting. So fprintf standard error, we had an error loading the file. That's good. It's telling us the file name we failed to load. It does not need to. It does not need to set the return value, but it does need to continue. Okay, on success, it's now going to try and use that. But instead of freeing here, we need to call free file with the buffer, right? Yeah. Let's see what we blow up. Multiple things. Returning int from a function with a return type of character pointer. Okay, so that was me starting out in the wrong direction. So the type of bytes read is a size t, and we will no longer. Oh, maybe we do need it there. I have to look at that, but we will for sure need it here. Oh, let's fix the indentation. Yep. Okay, so we're still using bytes read there. So we need the buffer. Do we have return val? I think we... I'm not sure, it doesn't make sense to have a return val that is of an error if it failed to read the third of the 5 files. I'm not real sure how I'd want to handle that, and since this is just a toy to experiment with, we'll just leave it as it is. Try to build it. Return val is undeclared in the top part, in the load function. Oh yeah, so... which I'm only using to get the result from, which I'm only using to get as the result from there. Okay, line 13, st undeclared. So 13. st is the struct, which I'm only using up here. And now on 36, expected declaration before the, is this a 36? Void free, okay, so free file that takes a character pointer. free file. Do I have a... do I have a parentheses issue here? Or a semicolon issue? Right, so I see... Okay, let me... What I'm looking at is the syntax highlighting, right? So, why is the, oh, now I see it. There was something off in the syntax highlighting. No, it was that. Right, so I was looking at the different colors between this function and free file for this, for the curly braces. And I couldn't quite figure out what it was. It was that extra parenthesis. Okay. What do we got? Comparison of an integer with a size t. Okay, so that's that is on the bytes read, right? Bytes read is a size t, but then that one will be fine, but it'll be this one because I have it as an unsigned int. And so, right? Comparison of integer. Okay, so this is on 49. Let's just go look. If bytes read. Oh, it's assigned value is why. Size t. Is that... It wasn't even being used up here, right? Bytes read is the return value of fread. The return value of fread is a size t. That's interesting. So here we are already getting into interesting, like, how do we deal with propagating errors up? In this case, the way that fread works is you have to look at error. And so I'll just let it propagate, right? So if anything further up the stack wants to know what the error is, it also has to look at error because it doesn't get cleared until you run another function that would overwrite it. So, and we just returned bytes read, that's fine. If it's 0, the behavior that we want to do here we can... Yeah, that's really painful because then what I have to do is, you know, basically what you should do is just not even check it here. Well, no. Now we still want to know if it's error and we want to close it. And then here, all we want to do is say if the bytes read is 0, continue. We actually don't even know if it's an error unless we check, right? What we could do is we could say if error, no, because we don't have the file pointer anymore. So we can't even really check it. So that's seriously awkward. Okay, when we get to the videos about error handling, that'll be something to think about. But what I'm going to do for now is we're simply going to say we won't output anything for this little toy program, and we will just continue. So there's, oh, but what we, so we will have closed the file and freed the buffer already at this point. So we don't need to call free file. So that is perfectly correct. So all we need to do is continue. There's nothing else to do. Then we iterate over it, putting out the characters. FP is undeclared on line 58. The file is already closed. The only thing we need to do is free it. There we go. Invalid pointer on line. Oh. So all we did was get a bad address invalid pointer. Yeah. This is where I need to deepen the skill set. Bin demo and Frankenstein. I tried to free an invalid pointer. That's interesting. I suspect my error is right. Oops. Here. Okay, so let's try debugging this. I think that the problem is going to be I want to get to line 19. So how do I set a break? Or make it break at the error. Wow. Things I don't know. So let's jump over. Oops, didn't mean to do that. I wanted to do that. I wonder if it's the sanitize stuff that is catching me right there. I mean, that's catching the error for me right there. Set break point in GDB. So it's just break, the name of a function, or the break and the name of a line number. Is it file line number? Is that how you do it? So if I do that and then I say break bin, whoops, source demo.c colon 19. Yeah, it seems to be, and then continue. Run. Using blah, blah, blah. It already exited. Okay, so let's try. I think I'm on the right path here. But yeah, I 19 was one line too far, probably. So let's break on line 4. So break has no. So it's source demo C line 4. Run list. Doesn't seem right. Doesn't seem like I'm breaking where I want to break. So 4 is the F open failing? Oh yes. Let's go to here. So when we run debug, we want to pass the Frankenstein file. So if I come over here and run debug and then set the break at source demo C line 4, and then I run, that did not do what I thought. Do that, break at source demo C line 4. Where am I current? Okay, so run it. Program is not running. So let's normally, okay, explicitly set a breakpoint. I can break on a function name or a line number or file line number, file name function on an address. Okay, let's do this. GDB run to break. How do I jump to a breakpoint in GDB? Blah, 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 blah. Just press C, which is continue. Okay, so let me, maybe it's failing before we get there, so, see, I should get to here no matter what, because it shouldn't matter when it's trying to open that file. But what I'm going to do here is I want to break on 48. So let's debug. Set a break on source demo 48, and then continue. We're not running, so first run it, then continue. And it seems like it's already exited. Starting blah 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 program thread debug using enabled, using host library blah inferior process exited normally. Why is it running to exit? Let's so there's one breakpoint. It's set on line 48. If I run it, it feels like it's not stopping there, right? Oh, 48 is... So why are the numbers here so different? So free file is on 30... Oh, list 50. So that just listed the lines around 50. You know, that's the point of this. Struggle through all this so we can figure it out. So GDB list more lines. So I want it to, when I do list, oh, I can actually list a function. Okay, frame. Oh, I see an error. Didn't notice it before. So I'm betting what it wants when we're running this way is it needs GDB needs to separate its parameters from the application. So we were still suffering the same problem the whole time where we weren't giving it a file, and so it was just falling out the bottom of the program. Or do we have to, okay, so that assumption was wrong. I mean, the assumption that we were never giving it an argument was wrong. GDB pass program. How do I blah, blah, blah. Args, -- args is what I have to do. So here, here, -- args, and then that. So now, oops. Debug that. So it doesn't look to me, okay, something's not right. So when we're calling debug and we're trying to run debug, to do that, so make debug. So what I think I'm doing is gdb-q bin demo. There's no demo in there. Tree bin. GDB bin okay, so that looks good. Okay, so let's take a look. So it's Franken EIN. So GDB bin demo debug -- args Frankenstein text. Ooh. Blah, 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 not in executable format, file format not recognized. So I think the args is not doing what I think it was going to do. GDB args, oh yeah, you have to do executable name. Jeesh. That's an odd, okay, so I was way off the mark. So what we want to do is -- args, the name of the executable, then the parameters. Debug that. Run. Okay, so we're at least successfully hitting the debugger and doing the thing. So I want to quit that. What I want to do is set, I think where I'm failing is right here. So I want to set a breakpoint there. We'll just start there. And now I can just run the debugger. I can do break at source. What I need to do is get it set up, macro set up, so that I can just be on that line and end up at a breakpoint there. But I haven't sat down and figured it out, and I don't remember how to do it off the top of my head. Break source, demo C, line 19, then run. Okay, finally, I landed it at 19, and so now what I need is GDB inspect variable. The value of a variable, viewing data. I just want one value. Is it print counter? So it's just print. Print buffer. Okay, so it's it's a pointer to a pointer. And so do I want the can I step? I'm in malloc. Okay, so step isn't what I wanted to do. It's next, right? GDB one line. It's a single line of input. There's no GDB. GDB run, continue, step, next. If you want to execute the entire function, one key press next. This is the equivalent to step over. Okay, I think it is. So let's just rerun this. And then do breakpoint, break at source demo 19 and list. Why did it complete? So did I not debug? It does not seem right. Make debug. Okay, so that worked. Break at line, so break in source on demo at line 19, and then run. And I want to print buffer. So this is definitely where I'm messing up, and I don't know. So like buffer was passed, the value that came in is that 978 value. So if I look at buffer now, print buffer, it won't have changed, I bet. That's the problem. Is it that I want to, okay, I'm just making stab in the dark here, but, so what I'm getting is a pointer to a character pointer. And the thing I want to do is I want to write this value, not oh, can this just be, it passes me a character pointer, it's unset, I let it I get a character pointer, which is just the temp buff. I let it set temp buff, but I just immediately assign. Oh, that's funny. Was I never testing to see if malloc failed before? In which case, we would do just what it's saying, but then the last step is to say, hey, buffer equals temp buff, right? And so down here, I don't actually need to pass the address of buffer. I just pass buffer. Oh, that's a seg fault. Okay, this video is going to be getting a little bit long, and I'm not actually going anywhere, so I'm going to break it up into multiple videos. And I need to figure out exactly how to do this. I don't think I'm thinking it through right. So if this is a character pointer, so it's holding an address, I want it to eventually hold an address, right? And if I pass that character pointer in here, and normally what I would do then is I would just do the malloc and assign the result to, actually, do I need to do anything? Can it just be buffer? Why would I need anything else? It is just a slot in memory. I think my, my brain is used to everything being a reference from, like Ruby. And okay, so that's a segmentation fault, but yeah. Normally, hey, let's do this. Let's go back and look at here, source demo, right? So before, I have a character buffer. I just assign its result to buffer. Well, if I just pass that character pointer in the call here, would I need to pass the address of the pointer? The character pointer, yeah, I think so, right? But then eventually when I do the alloc right here, so I think I'm going to have to break this down, and I have to go compare, like I'll run it in the debugger over here and see what happens, and then compare it to what's going on over here. I'm missing I must be missing a bit of indirection. What I think is going on is this is a value. You know, it's going to be a 4 byte or whatever the size is, 4 or 8. That'd be 16, 32. So it'd be an 8 byte slot in memory is what this wants to. It's a value that can hold a pointer, which is 8 bytes, right? And then I pass the value. No, I do want to pass the place in memory that this is, and then just to make it easy, I think what I'll do. I'm not sure if this is right. I'm just. Let's pretend it is a blah blah blah, a pointer, and then what I do is temp buff equals is a character pointer. Hold it. Let me write it the right way. So a character pointer to temp buff, and then I want temp buff though just to equal that. Why would I do that? I'm going to have to go look at some examples and come back and do this because it's escaping me. But this is exactly why I'm doing this, so that I can learn it. Anyway, I will see you in the next video.